Hey guys, I am Akash Dubey, and in today's session we are going to learn one of the very important concept, that is Raoults Law. And in this law we will be learning why this law is important and what is the statement of this law, and also we will be learning regarding the graph of this law. So without wasting time, let's start with the topic. So first of all, let's understand the concept of vapor pressure, because if we are moving ahead for the Raoults Law, so we need to understand what is the vapor pressure, as well as we need to understand what is called as mole fraction. So these two terms are very important for us to understand. So let's begin with the topic. So now what happens, my dear students? So first of all, just imagine you have one beaker, and in that beaker you have volatile liquids. Volatile liquid mean what? Volatile liquids are generally those liquids who get evaporated easily, basically at low temperature, you can say, or at room temperature, like petrol. Petrol is a kind of volatile liquid. So what happens once you will keep the petrol in open, so definitely that will get evaporated, right? So now what is happening over here? So the molecules which are present at the surface, so these molecules are called as surface molecules, and the molecules which are present at the center, or you can say downwards or at the bottom, so they are called as bulk molecule. So this bulk molecule experience force in all direction. So this bulk molecule experience force of attraction in all the direction. But the molecules which are present at the surface of liquid, they experience force of attraction in downward direction only. So this means that the kinetic energy of the surface molecule is high, and the kinetic energy of bulk molecule are low, right? I hope this is clear to you. Now just understand what is happening over here. So these molecules which are present on the surface, so they can escape very easily. So if this molecule will escape from liquid state to gaseous state, this process is called as evaporation. What is called? This process is called as evaporation. So I can write over here, from liquid to gas, this process is called as evaporation, right? Now what I have done right now, if I will close the container, so what is going to happen? If I will close the container, so in that case these gaseous molecule will start accumulating over here. Now in the next step, what will happen? These gaseous molecule again will get cooled down and they will get converted into the liquid. So here one more reaction will take place, one more process will take place, and what is that? From gas to liquid. And this process is called as condensation. This process is called as condensation, my dear students. Now, so there is a point, what happens when both of these processes are at equilibrium? It means that what you can see over here, for example, here we had liquid to gas conversion and from gas to liquid conversion. When this process reached at equilibrium, what do you mean by equilibrium? It means that when whatever the number of molecules which are getting converted into the gaseous state, the same number of molecule is again getting converted into the liquid state. So it's a kind of equilibrium. When the equilibrium is established between these two processes, so at that particular point, whatever is the pressure exerted by the gaseous molecule on the surface of liquid is called as vapor pressure. I hope this is clear to you. So this is your vapor pressure. What is vapor pressure? So at equilibrium, whatever is the pressure exerted by the gaseous molecules on the surface of liquid is called as vapor pressure. I hope this term is clear to you, my dear students. Now let's move ahead and let's understand what are the factors which affect this vapor pressure. So first factor is the nature of substance. If we have volatile liquid, as I told you, generally volatile liquids are those liquids which get evaporated, or their boiling point is in the range of 60 to 70 degrees Celsius. So such kind of liquid basically get evaporated very easily, generally at room temperature. For example, petrol. So for the petrol, the vapor pressure will be high. For the volatile liquid, the vapor pressure will be high because they have high tendency to escape from liquid state to gaseous state. For the non-volatile, the vapor pressure will be low. For example, you can consider organic solvent like benzene, right? Now, if I discuss regarding the second factor, so that is temperature. At high temperature, what will happen? At high temperature, the vapor pressure will be high. The reason behind this is very simple, because at high temperature, the molecule has tendency to escape, right? At low temperature, the vapor pressure will be low. I hope this helps to you and this is clear to you. Now let's understand regarding the mole fraction, my dear students. So let's understand what is this mole fraction. So mole fraction is nothing but this is the ratio of, and this is represented by zeta. So I can write as zeta over here. So this is what? This is the ratio of number of moles of one component divided by total number of moles of all component. For example, let's say we have one mixture, in that we have A and B. So I can write zeta A as Na divided by Na plus Nb. Na is what? This is nothing but number of moles of component A. And Na plus Nb is what? This is the total number of moles. For example, if we have X components, so in that case here zeta will be equal to, you know what? This will be equal to, for example, for the first component, this is going to be N1 divided by N1 plus N2 plus blah blah up to Nn, if N components are there, right? This is zeta 1. Now for the second component, like for B, zeta B will be equal to Nb divided by Na plus Nb. I hope this is clear to you. Also, you need to understand the sum of mole fraction of all the components will be equal to 1. So here I can write zeta A plus zeta B will be equal to 1. And for the N component, I can write zeta 1 plus zeta 2 plus zeta 3 plus blah blah blah, zeta N is equal to 1. I hope this is clear to you. Mole fraction is very much clear to you. Now let's understand regarding the Raoults law. So what is the statement of Raoults law? Let's try to understand. So what does it say? It says that for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. Let me explain you very clearly. What does it mean? For example, let's say you had, first of all, you had one component. Let's say this is A. So here if only A is present, so vapor pressure of A will be P naught A. This is what? This is the vapor pressure of, pure component A, right? If I have, let's say, if I have the second component as B, so P naught B will be equal to what? Vapor pressure of pure component B, right? So this is what we are going to have. In the next part, you need to understand if only one component is present, so it means that at that particular point, mole fraction is going to be 1. So here zeta A will be equal to 1 because we don't have any other component over here. And similarly over here we are going to have zeta B is equal to 1. Now what does it says? So if I mix A and B, here we are going to have two components into this, A and B. So the partial vapor pressure of first component means PA will be directly proportional to zeta A. So this is what Raoults law says. Similarly, for the second component, PB will be directly proportional to zeta B, and I can write it like PA is equal to K into zeta A and PB is equal to K dash into zeta B, right? So this is what I can write. At a particular point, So why I have written PA over here and PB over here? Because now we are mixing, A and B. If we are mixing both of these components, then what is going to happen? There will be change in the vapor pressure, and P naught A represents the vapor pressure of pure component, right? I hope this is clear to you. This makes sense to you. Now, what next we can do? If the value of zeta A will be equal to 1, so at that particular point this K will be equal to P naught. So I can write this as PA is equal to P naught A into zeta A. So this is what I am going to get, and here I will be getting PB is equal to P naught B into zeta B. So these are the two equations which I will get. So this is your equation 1 and equation number 2. Now, as per the Dalton's law of partial pressure, so here I can write as per the Dalton's law of partial pressure. So what is going to happen? As per this law, what does it say? It says that for a mixture of non-reacting gases, the total pressure is sum of partial pressure of all the components. For example, PT, if I have n components, so total pressure will be equal to P1 plus P2 plus P3 plus blah 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 plus Pn. It means that P1, P2, P3 and these all are basically the partial pressure of the non-reacting gases which are present in the mixture. Now, I can write total vapor pressure will be equal to PA plus PB. I can write this way. So it will become P naught A into zeta A plus P naught B into zeta B. So this is what we are going to have, and this is your final equation. Or you can put zeta A plus zeta B is equal to 1, and if you have only one component, so definitely what you can do, you can just put zeta A is equal to 1 minus zeta B, and you can put in this equation and you will get the same value. But this is the important one, and this is your final equation, right? If you want to modify it, definitely you can do it. Now the next part is the graph of Raoult's law. So let's try to understand. So what is happening over here? Now first of all, let's say we have first component, and when only first component was present, so at that particular point we were denoting vapor pressure as P naught, like that. So if I discuss over here, so here zeta 1 is equal to 1, so it means that at this particular point we are going to have vapor pressure as P naught 1 for the first component. As soon as it will start decreasing, so the vapor pressure will also start decreasing like this. So this is also decreasing. I am clearly indicating it with the pink color. Now let me write for the next one. For the second component, if only second component is present, so at that particular point the vapor pressure is going to be P naught 2, and we are assuming that P naught 2 is greater than P naught 1. We are just assuming, right? Now what is happening? If I will start decreasing its mole fraction, like for example from 1 to 0.75, again 0.5, 0.25 and then 0, so it will again start decreasing. I am marking with green color. I hope it is visible to you, right? So this is what you are going to have. So this is a kind of graph you will observe. Next important point is that if I will add this at this particular point, what you can observe, the first component was 0.75, so it means that at this particular point the value of P naught 1 is this one, right? So this pink color line which you can see over here. For the second component the mole fraction is 0.25, so here the value of this P2 will be equal to this one. If I will add this green and pink color line, so what is going to happen? I am going to get this black color line, which is nothing but the sum of these two. They are just above to each other, because they will start overlapping, so that is the reason why I am drawing them far away from each other. So here what you can just understand, so black color line is basically sum of green plus pink. For your understanding I am writing this way, and this and this green color line which you can see over here, again this value is going to be same. These both of these line will be same. Why? Because if I will remove this pink from the black, it means that if I will remove the value of P2 from the total value, so in that case again I am going to get the P1 value. So this is the reason why both of these value will be same. You can also draw over here and both the values will be same. You can also draw over here and both of this value will be same. I hope this is clear to you. And again what I will do, if I will draw a line, so it will become something like this, a straight line which I am drawing with the black color right now, this one, this line, right? So this way you can explain that P total will be equal to P1 plus P2. I hope this helps to you, but because this law is valid for the ideal solution and we don't have much ideal solution combination, so there is a lot of deviation observed in the solution when we try to understand the Raoults law. So those are positive and negative deviation, and definitely we will discuss those things in the next video. For this video we are going to discuss up to this point only, but let me tell you one of the very important thing. So what is the conclusion of this video? So the conclusion of this video is that if we have non-volatile liquid and we are going to add any kind of impurity into it, or we are going to mix any kind of volatile liquid or non-volatile liquid or whatever, so at that particular point the vapor pressure is going to get down. So this is what the conclusion of Raoults law. So it basically indicates that the value is going to decrease. How? Let me explain you. For example, PA is equal to P naught A into zeta A. If the value of zeta A will be small, if this is a smaller number, so what is going to happen? If this is a smaller number, if I will multiply it with the P naught A, so definitely the total value is going to become smaller one, right? So this is very important point you need to understand. I hope this helps to you. This is the conclusion of Raoult.